Okay, so in this question we have to graph another function that has some transformations. So we have another function that has some transformations. So here we have to recognize that we have the function f of x is equal to the quantity x minus 2 squared plus 2. And we want to describe the transformation from the base function. So here we have to recognize our base function. So our base function is just going to be f of x equals to that value of x squared. So that's just going to be a quadratic. So nothing too crazy, but we're going to have a quadratic. So I'm going to go ahead, I'm going to draw this in black. So I'll draw my axes in black. Try my best to draw as vertical as I possibly can. And then here will be my x-axis. And now for my base function, I'm going to have this parabola opening up. And he's going to look something like that. And he should be symmetric on both sides of the y-axis, but sometimes I can't draw that perfectly on the graph. So this is the graph of x squared. So now we have to recognize exactly what happens when we have x minus 2 quantity squared plus 2. So let's talk about our transformation rules, some of our transformation rules. First of all, again, as we saw in the last problem, if you have f of x equaling to f of x plus a constant c, you will have a horizontal, not a vertical, you have a horizontal shift negative c units. So you're going to go opposite the value of c. So here we're going to have a horizontal shift right 3 units. We're going to have a horizontal shift to the right 3 units because we have a negative 2. The opposite of negative 2 is positive 2. So we're going to have I'm sorry, not 3 units. What is wrong with me? We're going to have a horizontal shift to the right 2 units. So here is going to be to the right 2 units, and that comes from this value right here. So I'll even star that so we can see it. I'll start in green, and this will be this portion right here. So next, let's talk about vertical shifts. If you have f of x equaling to f of x, whoops, what did I just do? Sorry about that. If you have f of x equaling to f of x plus a constant. So the constant is no longer attached to the functional value of the x plus c. Now it's off to the side. Now you're going to have a vertical shift positive c units. So you're going to have a vertical shift positive c units. So I'm going to do that we'll do that in blue. So here, this will indicate this rule, and this will correspond to this 2 over here. So this 2 is going to be indicative of your vertical shift, and in green, this negative 2 will be indicative of your horizontal shift. So in reality, what we just described is the new vertex. We recognize here that we're going to have a horizontal shift to the right 2 units, so our vertex will be shifted to the right 2 units, and then we're also going to go up 2 units. So we're going to go right 2, and then we're going to go up 2. So we have a new vertex that's here. We still have leading coefficient that's positive, so it's still going to go up like such. So that will be the function f of x equals to x minus 2 squared plus 2. So we have a horizontal shift to the right 2 units, and we have a vertical shift up 2 units. So hopefully this helps you with this function. With this question. We could actually go back to look at 2 different areas. You could go ahead and look at how to graph quadratics. We could look at graphing quadratics. So if you wanted to find this section in your textbook or in your notes, you could use this to help you understand this question. You could also go back and try to understand transformations. So transformations will be another good area that you can review in order to understand how to graph this guy from the base function that originally occurred, which was x squared. So now let us bump down to this next question. So this question asks us to use the quadratic formula. Okay, so the first thing when I hear the quadratic formula, I know quadratic formula is synonymous with us finding where x equals to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. These tend to be the zeros of your function. They tend to be the zeros of your function because they have to solve the function ax squared plus bx plus c equals to 0. A quadratic function must be set equal to 0. If it's not set equal to 0, you cannot apply the quadratic formula. So this right here is the quadratic formula, and this right here is a quadratic function. In order for us to solve a quadratic function, we can use the quadratic formula, but the quadratic function must be set equal to 0. So in this circumstance, 8x squared minus 6x is equal to 8. We recognize this guy is not set equal to 0. He's in fact set equal to 8. So we can go ahead and subtract 8 on both sides. So we will have 8x squared minus 6x minus 8 is equal to 0. And I notice I have a GCF here of a value of 2, so I'm going to pull out my value of 2, and I'm left with 4x squared minus 3x minus 4 set equal to 0. And I can divide both sides off by 2, and that will give me 4x squared minus 3x minus 4 is equal to 0. So you don't have to pull out the GCF of 2. If you didn't see it, that's okay, because your quadratic formula will still apply the exact same way. You'll still get the same exact answer. We're just using smaller numbers. So in this circumstance, my a for my quadratic formula will be equal to 4, which comes from this value right here, your leading term, your leading coefficient of your leading term. Your b is equal to negative 3, and your c is equal to your constant, which is negative 4. So a, leading coefficient, b, the coefficient in front of the x, and c is your constant. So now we can go ahead, and I'll do this in green. I'm going to plug this into my quadratic formula. Actually, I'll do it back in black. I'm going to plug it back in, so I'm going to get x equaling to negative 3, because our b is negative 3, plus or minus the square root of b squared, and my b is negative 3 squared, minus 4 times a, but a is 4, times c, which is negative 4, all over 2 times a, which is a value of 4. All over 2 times a, which is a value of 4. So I've gone ahead and plugged everything in. Negative 3 gives me a value of positive 3, plus or minus the square root. Negative 3 squared gives you a value of 9. Negative 4 times 4 is negative 16. Negative 16 times negative 4 is positive 64. All over 2 times 4, which gives you a value of 8. So now we're going to take 64 and add it to 9, and we're going to get x equals to 3 plus or minus the square root. 9 plus 64 gives you a value of 73 all over 8. And we recognize here that we really can't do very much with 73 because I don't know, let me think, it was prime. 73 is divided by 2, is divided by 3, therefore 6. That is divided by 7. I'm pretty sure 73 is a prime value. So in this circumstance, we can leave our solution as x equals to 3, x equals to, why do I keep doing that? There we go. X equals to 3 plus or minus square root of 73 all over 8. So that's how we're going to solve and get those two answers. This would have been quite a difficult guy to factor, because if we want to factor, we would have had to try to find factors of 16 that give you negative 3, and there aren't any. So that's a good indicator that we would have had to use the quadratic formula to solve this question. So let us move on to this question number 7. This will be the last one of this segment. So we have to determine algebraically the max min, the value of the function of f of x equals negative 2x squared plus 2x minus 6. So first of all, it's asking us, do we have a max or do we have a min? So hopefully we all immediately looked at the original leading coefficient. Hopefully we all looked at the leading coefficient. If the leading coefficient, so if you have a quadratic, ax squared plus bx plus c set equal to 0, if you have let's set it equal to f of x. So let's set it equal to f of x So we'll have the set equal to f of x. If a is greater than 0, we know that we will have a parabola that opens up. If a is less than 0, we know that we're going to have a parabola that opens down. So in this circumstance, I hope we all see that we have a min. And in this circumstance, I hope we see that we have a max. So when it opens up, you have a min, and when it opens down, you have a max. And so since our leading coefficient here is a -2, we know we are going to have a value of a max. So now, since we determined we have a max, we have to find the max algebraically. So there's a couple different ways you can go about doing this. I'm going to go ahead and I'm going to solve this using the vertex formula. This will be negative b over 2a, and then f of negative b over 2a. So first of all, we have to find the x value. So this will be the x value. And this is actually equal to the max value. The y portion of your vertex is actually equal to the max value. So first of all, I have to find the x to find my y. So I know my x coordinate, which is going to be negative b all over 2a. That will equal to negative. My b is 2. My b is 2 from the value of 2x. My b is here. My b is also here. So I'm going to have 2 divided by 2 times a, but a is -2. So I have -2 divided by -4. So we have -2 over -4, which gives you a value of +1/2. So now if I want to find my y coordinate, which is equal to the max value, will just be the functional value of -b over 2a. So I'm going to have to find f of 1/2. So this will give me -2 times 1/2 squared plus 2 times 1/2 minus 6. F of 1/2 equals 2. -2, 1/2 squared gives you 1/4. So hopefully recognize that 1/2 squared is really 1/2 times 1/2. 1/2 times 1/2 gives you 1/4. Plus 2 times 1/2, 2 and 1 cancel, so we get +1 minus 6. -2 times 1/4, this gives you a value of 1, this gives you a value of 2. So f of 1/2 gives you -1 times 1, which gives you -1 all over 2, plus 1 minus 6 gives you a value of -5. So here we're going to subtract fractions. I hope we recognize that -5 is really -10 all over 2. That is really -5. So -1/2 minus 10 halves gives you a value of -11 all over 2. So remember, so -10 divided by 2 gives it -5. So all I did was just transform this to have a common denominator so we could subtract them. -1/2 minus 10 halves gives us -11 halves. So in summary, we know that we actually have an absolute min. It is the smallest possible value of our function. We have an absolute min, and we have an absolute min at x equals to, we have an x value of 1/2, and the absolute value itself, which gives a value of -11 over 2. So this actually is the min value. So this is the min value. If you want to be safe, you could just say you have an absolute min that occurs at 1/2, -11 over 2.